Good morning everyone. So today we'll be talking about IEEE 802.3, that is nothing but the protocol or standard designed for Ethernet. So we have already studied what do you mean by CSMA-CD. So CSMA-CD is nothing but a carrier sense multiple access collision detection type of access methodology, in which we can detect the collision of the packets, and depending on that the data transmission will take place. So CSMA-CD was used to send the data over the shared a single coaxial cable connected to all the computers. Now here we will be considering that the coaxial cable is utilized, but CSMA-CD is also utilized with the cable. Initially when the Ethernet was established, or when the Ethernet was evolved, at that time we used to have a coaxial cable, and after that when the speed demand or the baud rate demand increases, at that time we shifted to the twisted pair cables. So this 802.3 or Ethernet standard only defines, it is only defined for the MAC address. So we have already seen that the data link layer, you can separate it into two layers. First one is the MAC layer and second one is the LLC, that is a logical link layer. So LLC we are not talking about here. We will be talking about the MAC layer, so which is associated with the data link layer, and Ethernet is associated with this data link layer 802.3 and a physical layer standard of OSI model. Okay, so this is the topic we are going to discuss, and how it will be done, let us see, let us try to understand. Now there are different wiring cables that are utilized for 802.3. So we can call it as there are four types of cables that we use it for the data transmission. So you know that whenever the cabling is used or the medium access is utilized, then you have to connect the cable to the physical layer, right? So that's why physical layer came into existence, and MAC will also came into existence. So for that purpose these two layers are considered. So here the four types of cables are utilized. First one is 10 base 5, 10 base 2, 10 base T and 10 base F. Now here the meaning 10 means the speed you will be considering 10 is nothing but a 10 megabits per second. So that is a baud rate of your transmission. So 10, if I come up with 100, then the speed is 100 megabits per second. But here for a basic Ethernet or a standard Ethernet, the speed is 10 megabits per second. And base 5, base 2, base T and base F, this is related with the different types of cables that you are utilizing it, and it is also associated with the different characteristics. Now what do you mean by 10 base 5? So it is associated with the coaxial, and that is a thick coaxial cable. Okay, so what is the maximum length that you can cover? The maximum length you can cover is 500 meters, and the nodes you can connect are 100. Okay, so what is the advantage? The cable length is long. Then 10 base 2, it is using a thin coaxial cable. So there are coaxial cables are of thick and thin type. So thin coaxial cable, and that is known as RG58 type of cable. So you might be seeing nowadays in your home or for CCTV, if the coaxial cable is utilized, this RG58 type of coaxial cable is utilized. Or for your TV also, most of the time this kind of coaxial cable is utilized from your dish antenna to your TV. So this is RJ58 type of coaxial cable. Its maximum length is 185 meters, and only you can connect 30 nodes in that network. The advantage is it is low cost. Now the next technical name of cabling is 10 base T, where you will be utilizing the a twisted pair, just like a telephone wire. If you have seen the telephone wire, so it is a twisted pair. The maximum length is 100 meters, but the number of nodes that you can connect are the maximum, that is 1024. And the advantage is that it is easy to maintain, because a twisted pair you can connect it to the sockets, and that sockets will be directly connected to your nodes, so the maintenance becomes easy. And the next one is 10 base F. So F is related with the fiber optics, so you can easily remember this. So T means twisted pair, and F means fiber optics. Okay, so this is how you can easily remember these notations. So 5 and 5 here you can consider for 500 meters. 5 here you can consider for 500 meters, and 2 you can consider approximately 200 meters. Okay, so this is how the length or the cabling type that you can consider. Here you can see that for twisted pair 10 base T, the maximum size is 100 meters and 1024 nodes you can connect, whereas in 10 base F, fiber optics is utilized, and the maximum cover distance you can cover is near about 2 kilometers, and the number of nodes is equivalent to 10 base T. So the advantage of 10 base T is it is no noise interference. So noise interference is not there. So this is what the advantage of this fiber optics, because it is optical signal, so noise interference is comparatively less. Okay, then Ethernet, which works at a MAC layer. What are the basic characterizations or basic work of that data link layer? That we have already seen that it is used for data encapsulation. That means it decides the frame format, addressing, and error detection. We have already seen such kind of concepts in data link layer. And link layer management is associated with the CSMA CD, and one algorithm that is called as a backoff algorithm. We'll soon see what we mean by backoff algorithm. So this Ethernet is associated with these activities. So 10 base T, it is the most popular cabling method used in networking for Ethernet. It is also called as a standard Ethernet, and mostly it is used with the star topology. It is a simple and cheap to implement, and mostly opted with a RJ45 type of connector and unshielded twisted pair cable. So maximum cable length you can utilize it 100 meters, and the nodes you can connect is 1024. So this is the Ethernet frame format. So that is a standard of 802.3. It is a frame format of 802.3. So I'll say that it is a frame format for 802.3, because there are different formats utilized for different types of topologies. So for bus entering topology 802.4 and 5 are utilized, whereas for Ethernet it is 802.3. So it consists a 7-bit preamble, then SFD, that is a start of frame delimiter, so it indicates that it is a start of the frame, then destination address, then source address. So destination address and source address are the fixed one, that is a 48-byte globally unique address that is designed by the manufacturer, so we'll call it as a MAC address. We have already discussed about it. So it consists, depending on that, whether it will be a unicast or multicast, or whether it will be a local address or global address. So that will be decided by this one, and the type will be decided. It indicates that whether the protocol of encapsulated data is in which format it is. Then most of the times after that we'll be adding the data, and most of the times to have a standard format of standard frames, you need to add certain bits, that is zeros are added to ensure the minimum frame length. So this is called as a padding, and these pads are added, that is nothing but zeros are added to have a standard length of frame. So this will be added, and the final is CRC, so that is called as a cyclic redundancy check, and that is used for the error detection and correction. Okay, so this is how you will be utilizing the Ethernet frame format. Now Ethernet MAC frame address field, so it's source and destination address of 6 byte each. So there are two types of destination address. One is physical address, which is a unique one for each user. We call it as a MAC address, which is having a standard hardware address of that particular device and which is decided by that manufacturer. And the next address is a multicast address, where a group of users will be utilizing this one. So the first bit of the address determines which type of address it is. If the first bit starts with a 0, it is a physical address. That means it is the address of that hardware device, and if it is a 1, then it is used for as a multicast addressing. Then length of the field of other fields, we have seen that it is a 2 byte in length and determines the length of the data payload. So data field, it is in the range of 0 to 1500 bytes. Pad, it may be less than 46 bytes, and frame check, that is nothing but CRC, will be utilizing it for 4 bytes, and CRC32 technique is utilized for the checking of the MAC address. Now we know that whenever you are sending the data on a network, you have to wait for acknowledgement. You have to wait for the acknowledgement. So when a sender sends the data, so let us consider that here is a one host A and here it is a one host B. So host A is sending the data to the B, or he sends the frames to B, and after that B sends the acknowledgement. So this is an acknowledgement, right? So that concepts we have already seen in previous lectures. So this acknowledgement is received. Okay, but what happens when the collision occurs or when the acknowledgement is not received? Then in that case, this backup algorithm came into existence. So if the collision occurs, at that time, you have to choose a random slot of 2 raised to k type of, where k is the number of collisions the frame has suffered. Okay, then the congestion slot will be 2 into end-to-end propagation delay. So this is the propagation delay. So this is the propagation delay time. So this is the propagation delay time. That time into 2, it gets multiplied. So what happens? Let us see. In exponential, when A is sending the data to B and the congestion occurs or the collision occurs, so A assumes that A and B are collided, so KA and KB, which is equivalent to 1. Now they will choose a random time period, and since initially it is started with a 1, so they will so 2 raised to 1 slot they will wait for that one. Okay, so assume that A chooses 1 and B also chooses 1. So this is the slot where you will be choosing it. Now they will be choosing 1 and 1. Now they will wait for, now here it is a 15 microsecond is the time between the two stations. This is the 15 propagation delay time. We have considered that it is a 15 microseconds. So 2 into 15, so that comes out to be 30 microseconds. Again, after 30 microseconds, if again the collision has detected, then what happens? Now this k will be increased to 2. K will be increased to 2. Now the k is increased to 2. That means 2 raised to 2. How many slots will be there? So the range will be from 0 to 3. 1, 2, 3, 4, right? So the 4 slots will be there. So it will wait for 4 slots, and it will go for 2 raised to 2 time. So 2 raised to 2 into 15. So it will go for 60 microseconds, but it assumes that um, again it will wait for a next one. But here what we have considered, that assume A had chosen a time 2 and B had chosen a slot 0, and B has transmitted successfully, because between that period B has successfully transmitted, and after that you can see that after that 60 microseconds A will transmit it successfully. After these 45 microseconds with these 30 microseconds, A will transmit successfully. Otherwise, if both chooses the same 2, if A and B chooses the same 2, then this T will become 60 microsecond. So exponentially it is growing. Exponentially it is growing, right? It will wait for a 60 microsecond. And if it goes on continuing, that collision is detected, then the graph goes exponential, or the waiting period goes exponential. But how long it goes exponential? You have to wait at certain time. So it will go for the maximum of 15 retransmission. It will go up to maximum of 15 retransmission, and after 16th back off occurs, the transmission is considered to be a failure one. Okay. So this is how the exponential back off algorithm works, and this helps you in retransmitting the frames again and again if the collision is detected. But it will take place up to 15 retransmission attempts, and after 16th it will tell you that there is a failure and of the transmission, you cannot transmit the frame. Okay, this is how a binary exponential algorithm is working. Now the most important part is whenever you are considering, you are transmitting the data, because there are 1024, if you are using 10 base T, there are 1024 nodes are there which are working on the same network. So you need to consider the performance of Ethernet. What is that performance of Ethernet? So you need to consider the performance. We already know that whenever you are calculating the performance, you will be calculating with either with no load or full load. Either it may be of machine or either it may be of a computer network. So you'll be calculating with the two conditions. First condition is full load, that means everyone is trying to sending the data, and second one is at constant load. Okay, so Metcalfe and Boggs, they came up with this performance equation with the help of probability of retransmission by ignoring the exponential back off algorithm. So they have considered that let us see that the retransmission occurs at a probability P. The retransmission occurs at probability P. Then one station acquires a slot. Let us consider that one station will acquire a slot, and that slot A is determined by K into P into 1 minus P raised to K minus 1. Now what do you mean by K? K is the number of stations ready to transmit. So suppose there are 10 stations, then in that case K becomes 10. Suppose there are 100 stations, then in that case K becomes 100. Then P is the probability that station will retransmit. So that is the assumption, and that with that assumptions it is starting. Now when A will be the maximum, that means when a certain station will acquire a slot, when this probability will become a maximum, when this probability will become maximum when P is equal to 1 upon K. When P is equal to 1 upon K. At that time you can see that this will become approximately equal to 1, so this probability becomes 1. So when P is equal to 1 upon K, A tends to 1 upon E as K tends to infinity. When you go on increasing the K, so A tends to 1 upon E, and that will become a maximized station acquired by a particular station, or a slot acquired by a particular station. So this is the equation they have come up with. So this equation is very important, which is used for the performance measurement of Ethernet 802.3. So they have published the paper related to this one also. Now let us consider that there are J slots you will be considering. We have already seen the contention window in CSMA CD and CSMA CS type of communication. Then what do you mean by contention window? So considering that A into A minus 1 J raised to J minus 1 is the probability that the contention window is jth slot. So mean number you can calculate with the number of slots per contention is J slot into this probability. So here it is, the J slot into this probability, and this will be considered from 0 to that number of slots you will be considering. So that will give you 1 upon A approximately. Okay. So now let us consider that each slot is bounded by the time period 2t. Each slot is bounded by time period 2t. So this is the mean window size. So that the mean window size is bounded by assuming the optimal, that is P is equal to 1 upon K, that we have already seen, where A is equal to 1 upon E as P reaches. In previous case here we have seen as P tends to 1 upon K, A will reach to 1 upon E here, as we have already discussed. So considering these equations and substituting into this equation, the contention window size will become, that is nearly equal to 2 tau E, that is nothing but 5.4 into the window size of the time duration of that window size. Okay, so this is 5.4 into T. If P is the minimum, is the mean time transmission per frame. Now here it is not a small p, here it is a capital P. Okay, it is the mean time per frame, transmission time per frame. Now every time when you are talking about the performance of the channel or the performance of network, we will be talking in terms of channel efficiency. Okay, we will be talking in terms of speed, we will be talking in terms of channel efficiency. So this channel efficiency is decided by P upon P plus 2 tau divided by A, where let us consider that you are considering the frame of length F. So F will tell you the frame length, B is the bandwidth of your channel, L is the length of your cable, and C is the speed of light. So P is determined by frame length divided by bandwidth will give you the transmission time per frame. So this channel efficiency, now it will be reduced to channel efficiency is equal to 1 upon 1 plus 2 BLE upon CF. So you can see that as the BL increases, that means bandwidth and frame length increases, the channel efficiency decreases. So this is how you can find it out. So if bandwidth increases and cable length also increases, then in that case your efficiency decreases, so channel efficiency will get decreased. So this is how you will be calculating the performance of the Ethernet. Okay, now you can see this is a chart where the number of stations are trying to send the frames. So you can see the number of stations, as it increases, the channel efficiency will also decreases. The channel efficiency will also decreases. So you can see the channel efficiency is decreasing. In each case it is decreasing. The number of frames you are increasing. As the number of frames also increases, the channel efficiency is also decreasing, but the channel efficiency you need to go up to highest one. So for that purpose you need to consider that one, and considering that you can see that if the number of frames increases, the efficiency increases. If the number of frames decreases, but as the number of nodes are increased, the channel efficiency is decreased. So we have already discussed about it. So we will start with the next concept related with the higher version of Ethernet, that is the standard Ethernet 802.3 is fast Ethernet. Now what is the requirement of this fast Ethernet? Though fast Ethernet, that means the Ethernet was evolved in mid 90s. Then at that time the speed was only 10 Mbps. Now as the internet or other networking devices are enhanced and the speed requirement is also enhanced, so there is a need to increase the speed of the Ethernet. But considering that all the previous requirements that need to be considered, so the speed has to be increased to 10 Mbps to 100 Mbps. Now the speed is increased from 10 Mbps to 100 Mbps. Okay, so this 100 Mbps generation of Ethernet is called as a fast Ethernet. Okay, now the designer of the fast Ethernet need to be make it compatible with the standard Ethernet. Now consider that one device is working at 100 Mbps and other device is working at a 10 Mbps in a same network, then they should be able to communicate with each other. So that compatibility that designers need to be considered. For that purpose, what they have to do, they have to consider the max sublayer which left unchanged, that means frame format, maximum size and minimum size, that remain unchanged. The only thing is that what you have to increase, you have to increase the transmission rate with considering the standard features of standard Ethernet. Okay, so goal of the fast Ethernet is to upgrade the data rate to 100 Mbps from 10 Mbps, make it compatible with the standard Ethernet. Standard Ethernet is utilizing the standard framework that we have already seen. Keep the same size of 48-bit address. That means the address of MAC address should be that is the DA and SA should remain 48-bit. So that is the goal of fast Ethernet, and keep the same frame format. So frame format, it should be same one, it should not change. So considering that the designers, where they came up with certain ideas, in previous case we have seen that they have used the coaxial cable and they will be using star type or bus type of or ring type of topology also. But here in this case, in fast Ethernet, they will be utilizing a star topology with a maximum size of network with a 250 meter instead of 2500 meters in standard Ethernet. So the cable length is reduced. So if the cable length is reduced, efficiency can be increased, as we have seen in performance. So fast Ethernet uses the medium access. Which type of access it is, access technique it is utilizing? CSMA-CD access method it is utilizing, with a buffer to store a frame and full duplex connection. That is very important. It will be utilizing a buffer at LLC and full duplex connection to make each host, to make the transmission medium private for each host. Okay, so the transmission becomes a private and it is a full duplex, and it is utilizing a buffer with CSMA CD type of techniques. So fast Ethernet uses this kind of techniques. So one more feature added to fast Ethernet is auto negotiation. Auto negotiation means, as we have already discussed, there are two devices which is of, one is of a standard Ethernet and other is of fast Ethernet. So these two devices are, if they are in a same network, they should be able to communicate with each other, and this auto negotiation facility or feature which is added to this fast Ethernet, it will be giving this facility to fast Ethernet to have an interaction with standard Ethernet devices. So this allows you to incompatible devices to connect with each other. For example, we have already discussed 10 Mbps can communicate with a 100 Mbps, but the disadvantage is that they have to communicate with a lower rate. That is a disadvantage of this system. That means 100 Mbps cannot work with a 100 Mbps with the 10 Mbps. So 100 Mbps has to communicate with that 10 Mbps with the same speed of 10 Mbps. So 100 Mbps has to reduce its rate. Okay. Now to allow one device to have multiple capabilities, and it allows one station to check the hub's capability also. So multiple devices capability can be checked, hub capability can be checked. So this is the auto negotiation feature that will get added to the device. Now it will be using, we have already seen in standard network, standard Ethernet, it will be using 4 type of cables, but fast Ethernet it will be using 100 Mbps. Now here you can see that in previous case we started with 10 base T, right? 10 base, I'll write only base and T. Here 10 means the speed is 10 Mbps. Now here 100 means the speed is 100 Mbps. Now base means TX means it is a twisted pair cable and it is of category 5 UTP cable, that is unshielded twisted pair cable, or single shielded twisted pair cable, you can also utilize it, which creates a data rate of 120 Mbps at the maximum size, or that speed you can achieve it with this TX cable. This is a 2 pair, this is a 2 pair, that means 2 pairs are utilized like this. This is a 1 pair and another pair is there which is present over there. So these 2 pairs are utilized for communication. Another cable is utilized 100 base FX. Now FX means the 2 pair of fiber optics are utilized. So implementation is of 2 pair, right? 2 pair and 2 pairs. So 2 pairs of fiber optics are utilized, and the speed you can get it of 100 to 125 megabits per second. Now there is one more cabling technique or implementation technique is there, 100 base T4, which uses a Cat3 type of cable. Now this Cat5 and Cat3, they are having a different capacity. So here you can see the capacity is of 125 megabits per second, and here you can see the capacity is of 100 megabits per second, and you can go through the various net sources where you can find what is the difference between category 3, or which is also called as a Cat5, Cat6 or Cat4 category type of cables. You just find out what is the difference between all these categories. So these cables are utilized. The only thing is that here the 4 pairs are utilized. Here the 4 pairs are utilized. Now in previous case 2 pairs were utilized, and here in this case the 4 pairs are utilized. So this can be summarized in the table like this. So implementation is of 100 base TX. You will be using either a UTP cable, the maximum length is of 100 meters, 2 wires you will be utilizing, and there are certain encoding techniques that are utilized for the transmission of the frames. So these encoding techniques, if you are interested, you can go through the books, or you can refer to the standards of 802.3 related to this fast Ethernet. Then 100 Mbps 100 base FX, that will be utilizing the fiber optic cable. The maximum length is of 185 meters. The 2 wires are utilized, and the same, but here the coding technique is different one. Now that is NRZ means return to 0. 100 base T4, it is also using a UTP cable. 100 meter is the, but the wires are utilized are 4, and encoding technique will get changed. Encoding technique will get changed. So this is about fast Ethernet. This is about fast Ethernet. Now again the speed requirement is increased over the period. Now the speed requirement is in terms of gigabits. That means 1000 Mbps you will be expecting. So as the time elapses, the requirement of speed is going on very high. You require a very high speed networks. So the Gigabit Ethernet came into existence. So the need of even higher data rate resulted into a design of Gigabit Ethernet. So here you will be designing it for 1000 Mbps. 1000 Mbps. So IEEE came up with a new standard, that is, or amended of 802.3. So they came up with 802.3Z. So this Z will tell you that okay, Z is related with the Gigabit Ethernet, but it is, the base is a same one, that is a standard Ethernet, that is 802.3, right? So it is a standard Ethernet, and it is an amendment to that one which resulted into 802.3Z. So what are the goals of Gigabit Ethernet? So the goal is you have to upgrade the data from 10 Mbps or 100 Mbps. So previously it was 10, now it is moved to fast Ethernet 100 Mbps. Now again the demand is increased, now you have moved to 1000 Mbps. So that 1000 Mbps is nothing but 1 gigabit per second. Okay, so you have to upgrade the rate. You have to make it compatible with either standard or fast Ethernet, right? You have to keep the addresses same. That means device address should be kept 48 bit same. Then you have to keep the frame size same. Now you have to keep the same minimum and maximum size of frame lengths. So what is the minimum frame length and what is the maximum frame length? That also you have to keep it same, because you have to communicate with these standard and fast Ethernet. And support the auto negotiation. We have already discussed. That means this 1000 Mbps devices or Ethernet should be compatible to discuss with 100 Mbps, or it should be compatible to discuss with 10 Mbps. But whenever such communication occurs, it will occur at a lower rate. Okay. Now there are certain changes in approaches. So Ethernet, this Gigabit Ethernet is utilizing the medium access, that is a medium access with a full duplex or full half duplex. So in most of the cases the full duplex is utilized. So full duplex mode is utilized in Gigabit Ethernet, and the care is being taken that there should not be any collision. So maximum length of the cable is determined by signal attenuation of the cable. So collision is not detected, or the collision is not there because of full duplex mode. And the only problem is that the maximum length will be decided by what is the attenuation of the particular cable. So if the cable is too long, then the attenuation will be there. Then in that case you may require a repeaters type of devices. So these repeaters will enhance the signal and again send it. Then Gigabit Ethernet is also designed to connect two or more stations, or in many cases it is also required to have more devices, like 3 to 4 devices, or many hubs or switches you can connect, or many star topologies you can connect with each other. So basically you can have a star or tree type of or point to point topologies that can be utilized for Gigabit Ethernet. So in previous case also, standard Ethernet, it supports bus type of topology or star type of topology. Fast Ethernet, it is supporting a star type of topology. Gigabit Ethernet, it is supporting a star topology with number or several star topologies that can be connected. So we called it as a tree type of topology. So Gigabit Ethernet can be categorized into 2-wire or 4-wire implementation, as previously we discussed in fast Ethernet. So the only thing is that here the words are added, X type of words are added to this one, SX, LX. So depending on short wavelength or long wavelength, so these techniques are utilized. Now here you can see that TX, FX were not there. Now here in this case you will be utilizing the fiber optics. Here in this case you will be utilizing the fiber optics, and you can see the difference in the length also. So now it starts with 1,000. Now it starts with 1,000 base SX. SX means you will be using short wave for the transmission purpose. Short wave and long wave, you have already gone through your communication techniques. What do you mean by short wave and what do you mean by long wave? You might have studied in your subjects like radar and microwave technologies and electromagnetic type of techniques. So you know the concept of short wave and long wave, so I'm not going to discuss it. And these techniques are utilized along with the fiber optics. So you can achieve the high speed with a maximum length, so that you can have the 2 wires connected to that one, and the encoding technique will be changed accordingly. Now LX will be utilizing the long wave type of technology, and the maximum length you can go for with the long wave is near about 5 kilometers. Now 1000 base CX, that will be utilizing STP type of, that is a shielded twisted pair type of cable, and the maximum size is of 25 meter, maximum length is of 25 meter. And you can go with a T4 where you will be utilizing the 4 pairs cable with a UTP. So the maximum length is of 100 meters. So whenever you are going with a T4, you just see that the maximum length is of 100 meters, and you'll be achieving the high speed network, or that is called as a Gigabit Ethernet. So this is how we have seen the 3 transitions of standard Ethernet, its performance, then fast Ethernet, and the topologies and the implementation techniques that are used by fast Ethernet, and Gigabit Ethernet with its implementation and access methodologies that we have seen. So with that we stop here.